Okay, and now we're going to get into a little CAD and CAM programming for the machine. What you're seeing on the screen right now is a model of the fixture that I've drawn that we're going to use to make the parts for the mill stop. But right now we're going to be focusing on this clamp right here that holds the two pins on the fixture. And in order to machine this, what we have to do is we have to open the part up. So we'll open the component by itself, and you can see where the world origin is in relation to this part. We would have to move it in order to machine it, but we don't want to move it here, because if we move it here, it'll move the part in this assembly, and we won't want to do that. So we have to start a new design, they call it here, just a new file basically, and we got to go back to the part here, and we got to select the solid, and we're going to copy it here, and we're going to go back to this new design, we're going to paste it. Now we can move it, and it won't move it in the model because we're basically making a new design here. So we're going to move it to the world origin to begin with, and then we're going to select this top face, and we're going to move that face down to the origin point. So that would be our Z0 in the machine. And then we're going to select this face here, and we're going to move it to the Y origin. Oop, not like that though. We got to select the whole model, and then we got to select the face, and then we got to move it over here. So now we have it repositioned for the machining, and then we're going to go over here and we got to save it. Actually, I had one already saved here, I guess, as this pin clamp -1 SAT. We're saving it as an SAT format, ASUS text file format, so that we can bring it into the CAM software. Okay, now that we got that done, we can go over here to the, well, this is the CAM software here. I already had it open, and we're going to start a new file, and we're going to use the template for the little Haas TM1 mill that's behind me here. So we're going to open that up first, and then we got to open, and we have to merge a file of this model into it. So we got to scroll over to where I saved that right here. Here it is. We'll import it into the software. Okay, now I'm going to select this model, and I'm going to put it on the solid model layer, just so we can organize things a little bit here. Then up here I'm going to select the geometry layer, and we're going to make wireframe geometry of this model, which in this software, the Esprit software, they call it smashing it. And you got to make sure you've checked wireframe and you got some kind of tolerance here, and then you say OK. If I turn off the solid model here, well, it should be on that layer. Let's see where it is. Yeah, we should be able to see the wireframe geometry by itself, which we're going to use. Actually, we're going to use more of this wireframe geometry in this case to machine with, rather than a solid model. I'm going to put this layers on the feature layer. In a minute we're going to define some features for machining around this. For right now, we're going to define the stock for simulation, which is going to be here in this software. And right now it's set on block, so we're going to, that's what we want. So we're going to select the model, and then it's going to put a block around that model that is it the actual size of the model, but that's not our stock size. Actually, it's a little bit, our stock is a little bit larger than this. The thickness of our stock is exactly what we want to machine, but the width of it, if I measured it here, is say about 2.1 inches, and this is the distance from here to here, and where this starts is minus 1.9 right now, but actually we want it to be that's the total width of the part, so 2.1. I'm doing this on the calculator right now so you can't see it, but minus 1.9, and we divide that by 2 plus 1.9. It's going to start at minus 2 inches in Y, and the length of this material, if you measure with the calipers here, is about 3.7 inches, and half of 3.7 is what, 1.85, and we got to add that, so we have a stock up here, and we say okay. So now we should be able to start the simulation and see that, oops, see, I got something wrong. See, I got to change something here. Minus 1.85. And we have to update that. And we say, okay, now our stock should be in the right place for our simulation. Okay, the first thing we're going to need is we're going to need a trim profile of the stock in order to trim our tool path off to. It'll be easier just to draw a simple profile to do this for it. So we'll select a line and we'll offset this. Remember, on our stock definition it was 2 inches this way, and then it was 2.1 that way, and then this was minus 1.850 this way, and 1.850 this way. And we're going to trim off, or we're going to actually keep what we want here. Now we're going to define a manual chain, they call it in this software. It's a feature just of this stock profile. We're going to rename that stock up here. It doesn't have to be named anything, but we're just going to do that so we can keep track of things. And I'm going to change this to the features layer here just to organize things a little bit. And we're going to make us a manual chain around the part here. Basically selecting all the geometry features of the top of this profile. There's other ways to do this, but we're just going to do it this way. It's simple, relatively fast. We're going to end it right there. And we're going to machine that down a little more than half the thickness of this part, which will be 0.625. So we're going to go 0.675 maybe down with that, like that. That's our profile going all the way around the part here, but we're going to make some additional profiles just to make this roughing off a little easier. That would be basically our finish pass going around the part. And because this part's symmetrical, we can actually use this same program, and just, when we flip it over, we'll just run the same program again to machine off the other side. The only reason I'm doing it this way is I just happen to have this stock that already was 1.25 inches thick, and it's not that critical that for this just a clamp, and if we have a slight mismatch in certain areas around here, it really doesn't matter too much. What's going to be holding the part down, we're going to machine that radius here and this radius here later, and that's really the most critical part of the whole thing, and maybe the hole being on center line. The rest of this is just a clamp, and it doesn't really make too much difference. So we're going to do it half and half and just flip it over, run the same program. So we want to eat out some of this stock here in these corners. Otherwise we'd be milling a full cut, full diameter cut through these areas, and we don't really want to do that. So let's define extra profiles so we can cut out some of this stock here. I'm gonna turn this selection to just geometry, so this makes this a little easier to do, even though it doesn't seem to do it sometimes. So we're gonna take that profile, and we're gonna also go down 0.675 with it, and then we're gonna make another one over here, just the same thing basically, continuing on around the part, but we just want to take these corners and rough them down separately, and we'll trim the toolpath to this stock profile that we have here. So let's just do the first one here, and we'll go over here and we'll call it I'll tell you what, let's see if we got a tool defined. I defined this tool earlier. I'm going to change the tool number to 4 because I noticed I have a number of 4 tool in the machine that's already the right size. So we're going to do that first. Then we're going to go back here to the contouring. We're going to reselect that, and we're going to leave those alone. And I think we'll make this, let's try 4 passes going inward. That's going to be 4 passes. Well, you'll see in a second. And I'm going to go down the depth first and then move outward instead of doing the width. You'll see how that's different. I can show you both ways just so you'll see. Finished stock allowance, say 10 thousandths. We're not going to put any finished stock on the floor because we don't care. There's no floor here actually. And these are the lead in and out movements. It'll start 65% of the cutter over. We might have to increase this to miss this stock. In fact, let's try 80%, and here we'll try 20% of coming outward. See how that looks. Let's just see how it looks. For some reason it doesn't like my tool selection here now. I think because I changed the tool in mid. Let's just reselect it. It brings over the same information on these things. Shouldn't have to keep refilling it out on the oh, I gotta select the trim feature here. Okay. So that's the toolpath for this. Let's see what this looks like on the simulation on this side. Slow this down. See, it's hitting right here, so we gotta increase the I'm gonna rename this it brings over the name that it was last used on the last program, so to rename it there. Let's go 100% of the tool, and we'll go 20% feed out dimension. Just see what that looks like here now. Okay, that looks pretty good. I'm thinking to rough this, maybe we won't take that deep a depth of cut. We'll go equals 0.675 divided by 5. We'll take it in 5 cuts down, like that. I'm going to set something here so we can actually see this simulation. It's doing it every 10 moves, and we want them to be able to see it. Just load it down a little bit. So we're just getting rid of this material in the corner here, so we don't have to have a chunk of material dropping off on the second side, basically, is why the reason like that. Okay, that worked pretty good for there. So what we're going to do, we're going to take that and we're going to copy it and we're going to paste it on this other profile here. Let me do that again for some reason. I'm not sure. Oh, I don't have any depth on that profile. That's my problem. That's why it didn't give me any depth. 0.675, right? Now it should give me, forgot to do that. It should give me the depths. And I'm thinking, looking at this, that I'm going to make a couple little adjustments here. Let's see if 80% will clear the material here, and we're going to go about 30% to get out to the full edge of the material, maybe about 35 here. Let's see if that hits anything. Oh, what are we doing here? Let's see. This pass here is giving me a problem. See what we get when we put 5 passes on here. Nothing. Sometimes I don't really want to increase the lead in there. Let's try the step over amount. Let's just make it 4. We'll go back to 4 here. Let's go 65% maybe. That looks a little better. I'm not sure if we're going to get rid of that whole corner that way. Oh yeah, okay. Let's see if I put in 5 passes here. See, it's going to hit again here with this lead-in movement, so we don't want that. Go back to 4. Go slightly more, 55. Let's see if that still isn't right. Nope. 50. It'll clean it off like that. Let's see what this one looks like at 50%. Let's see what the whole thing looks like. It's taking a little bit deeper cut right here, but on this first little chunk of the corner, but it'll probably be alright. We'll let it go like that. So we're just getting rid of all of that stock in the corners. And if we wanted to really be clever, we could put an increased finish stock on here so that we take a little more off the profile cut. Which, we could try that. Let's see what it does. Let's put a finished stock allowance of 60 thousandths. Let's see what that on these. And 60 on this. Let's see if that gets us. Oop. I entered that wrong. 60. Not 600 thousandths. See if we can go even more. Let's see what happens. 0.1. Okay. Now, that was just the one side because I had it selected. Oh, it doesn't like that now again. Let's see. I'll go back to this 0.060 on both of these. You'll see in a second why So I'm going to copy one of these and I'm going to paste it onto this outside profile. See where we come up. So we don't want to do that. Well, let's see what that looks like. We're just going to suppress these. Let's see what it looks like. If it hits anything. Might work just like that. I think it's going to hit something up here when it tries to do that profile. See, it's cutting a lot of air. Yeah, see it hit and collided there. So what we want to do is just change this to one pass like this, and we don't need that much overlap on the tool. In and out feed movements, we'll say 20% for those, and the distance coming out's all right. We're gonna do a radius going in to kind of maybe blend that in a little. Oop, we don't want to do it on both ends. This software automatically changes everything on you, and we don't need that big of a lead out. 0.265 is a little bigger than the radius of the tool, and like this. That might still collide there. Well, let's try it. Yeah, it's colliding with the stock still right here. So we got to make a little bit more of this. 1.375, we'll say. 265. Okay, we got to unsuppress these two, and we'll select that one. We'll see the simulation. Oh, we got the stock set the same. Stock, we got to set this to 0.005, we'll call it here, and then we're going to do a finish pass on this one, which we are going to do. And we're going to do that at 3,000 RPM, 20 inches per minute, maybe a little faster, 24, 30. We're actually rapiding down, so we don't need to even worry about this plunge feed rate, but well, let's see what that looks like. So it's going to rough down in steps here, and then do one finish pass after it roughs the steps down. Now, we can actually tell this software to put corner brakes on these corners. Might as well do that while we're here. Be in the advanced strategy, clockwise, let's put 15 thousandths on there. So now this tool should put corner brake on every outside corner on its finish cut. You see the difference here? It's got a little corner brake. Okay. Okay, so that's basically the milling profiles we want to do. We're just going to use one tool to do this with, and then we're gonna flip the part over, like this, and we're going to do the other side, but it's going to actually just be the same exact program. So that's it for the cam part, except for processing the code, which we can go in here and we can set that parameter or whatever it is. We call this pin clamp -1, we'll call it. Program number, well, we'll leave that alone. We can rename that if we have to. And this, we want to select OS 4th axis wrap. It's I don't use this machine a lot this way, so I gotta figure this out every time I do it. Which post processor? TM1. Because I don't. See if I got one saved here. I'm gonna stick with this one here and see what that gives us. Might be all right. I'm gonna browse to the directory we want to save this in. Just save it in the 5-axis mill stop, and we'll call this again pin. Oh, what do we call it? Clamp. Pin clamp. -1, right? Okay, we'll process the code. Let's see what the code looks like. Somebody wrote this post processor, and we don't really care about any of this stuff here. Let's just see if this looks like it might work all right. I mean, it doesn't look like it's turning the coolant on, but let's see if we're putting tip comp, our cutter comp on. Yeah, we are for this profile. This looks like it might work all right. So we'll leave this alone. We might have to add an M8 here. I'm going to jump over to a different software to actually download this to the machine, which I got to hook my cable up and everything. So we're going to open this up in a this Predator software. I like to use this. It's going to be this right here. And let me get the machine all ready to go and everything, so I'll be right back with you on this in just a second. You may have noticed that the title of the description of the tool is off. I got in such a hurry I didn't change that in the tool setup. Here we are touching off the Z-axis with the probe on the raw stock. And now we're going to touch the Y off, or set the Y 0. It's going to go probe both sides of the stock and set it in the middle of the material. You'll see it kind of jumps over there a little bit. That's the center of the material. Now I'm going to manually jog it over in Y and down in Z, and then run the probing cycle to get the Y offset 0 point. And there it is, it's touching the Y off now. This next segment, I forgot I didn't have the camera, or I didn't have the camera turned on. I had to restart it. I don't know, the GoPro cameras, you can't tell sometimes you got it on or not. And so basically we're cutting the air of the first cuts because I forgot to turn the camera on. Okay, now I sped up the video so we don't have to go through all this, you know, at normal speed. It's going about 2.5 times the normal speed right now, just to get through this machining segment here. I don't know if you guys are interested in seeing this stuff, but to me, I've watched it so many years, it's kind of like a little bit boring to watch just the tool machine away, you know. But, you know, if you're interested, I can slow it down, you know, in future videos. But to me, it's kind of like, I just want to see what it's doing, have it happen quicker. And it just makes the video longer. It takes longer to download it, or upload it, I should say, to YouTube. So try to make these things as short as possible. But I did want to show it machining around the part the way you saw the program on the computer do it. Here in Houston, it's awfully hot, at least this time of year, and the background noise you hear in a lot of the videos I've been making is this air conditioner just right next to me here. It's a real small space in the garage here. Oh, I don't know, it's probably like 10 or 12 feet by 20 feet is the space I have these machines in. I got the computer here on the bench, and the air conditioner is right next to it, so when I'm filming and stuff, you hear that noise from the air conditioner. I've turned it off right now, trying to make it quieter to do this voiceover thing, but still, I don't know, it's kind of noisy. I've made a soundproof room for the air compressor here, so you can hardly hear it when it's running, but the air conditioner, you know, you can hear it pretty loud. And I don't know what to do about that. I don't know if there's some kind of directional microphones or something I could use, but right now I'm just kind of living with it the way it is. And also, such a small space, the machines make quite a bit of noise. They sound a lot noisier on the video tape than they really are, because of the sounds bouncing off these walls in here. And that's pretty much the finish of the first side. And I'm going to clean things up and flip the part over. But first we've got to set the 0 point now that we don't have a good edge to probe on because it's overhanging. I was checking the width of that just to see if it was pretty close. It's supposed to be 3/4 of an inch. So in the next segment we put a gauge block in there and set the mill stop over there, so we probe the x-axis here and then add half the width of the part onto it so that it sets it over in the center. So that's what I'm doing right there. And then I go and probe the y-axis, which will be my new 0, is actually at the vice jaw, basically right at the vice jaw. And that's the way I did it. It's not a real accurate way to do it, but it's good enough. This is just a clamp. And if we get a slight amount of mismatch on the first side of the second side, it doesn't really matter that much. Although actually it turned out it worked pretty good. Well, you'll see at the end of the video. So I probed the new Y0 there. Then I'm going to jog the probe away. It sounds kind of loud, that noise, doesn't it? The jogging the machine. Take the gauge, the 1, 2, 3 block out of there, and then put the real part in, up against the stop, tighten the vise, and hammer the part down a little bit to make sure it's down on the parallels. So I'm checking it. The parallels are kind of loose right now, so I'm going to hit it with a dead blow hammer. First I got jog the probes kind of in my way there, and hit it with the diplo hammer a little bit. Check the parallels again, make sure they're tight on both sides. And then we're going to go to machining the second side here. It's coming down to do that's the tool change you're hearing, the air blowing, the tool changer. Come over here. I didn't like the frame of the picture, so I kind of moved the GoPro camera a little bit here just to get it framed better in the center of the screen. Okay, here again I'm showing a little bit of the first cuts at normal speed, and then it's going to speed up to about 2.5 times the normal cutting speed, so we kind of get through this quicker. And the sound kind of cuts out when you do this. I'm not sure. I guess that's, I don't know, this software that I've been using, maybe that's just automatic with it. When you change the speed of the video, it mutes the sound. I guess it's just as well, it would sound kind of funny. So we're just eating off the corners here, so that we make our profile cut. We're not cutting a full diameter of the tool going around inside those corners. So it's almost got it there. It's going to come around, cut around the whole part here in a second. You have to kind of excuse how dirty the machine is. I mean to clean it up, but I never get around to it, and then I get busy with something else and at work and everything, and I know it looks kind of filthy. Someday I got to get around to cleaning it up. But fortunately, I'm the only one that uses this machine, and so it's not like somebody's coming after me. In a regular machine shop, that would be like a really pretty bad, I guess, breach of etiquette or something, that if you left the machine this dirty and the next machinist has to come clean it, you would pretty much catch hell for that, or at least in the days when I started working in machine shops. But I'm getting kind of lazy about that lately. Okay, here's how the part turned out. The mismatch was pretty good. It was a lot better than I expected it to be. Here's another view of it standing up. So this video's getting kind of long, so I was hoping I could show this whole part being made, but it takes a lot more time than you'd expect. But anyway, this is the next setup, so I guess I'll have to wait till the next video to get this part complete. So thanks for watching, and see you later.